Well, welcome back. Today we're going to be discussing vernier circuit boards, how to do certain things. On here, as always, here's our equations. Today our objectives. We're going to learn how to hook up a multimeter to read voltage, and we're going to learn how to hook up a multimeter to read amperage. Right here is what your vernier circuit board is going to look like. I'm going to draw in some wires here that are going to represent wires that we'll be hooking up. We're going to be hooking up wires that go from our positive terminal up here, and we're going to be connecting it down to here. So there's one wire, and let's say we're going to hook just one wire up in series. So then I might hook another red wire over here. So what we've done now is we've hooked the EMF, which is our battery source here. We've gone through our one resistor, which is the light, and we're going back over here to the negative. Well, you guys are going to have your multimeter. Let's give you a little multimeter over here. Here's our multimeter. And coming out of the multimeter, we've got our little dial here. And you've got these ports down here at the bottom. Well, first of all, let's talk about if we wanted to hook up we want to measure the voltage. The first thing we're going to do is we're going to have our ground, our common, and we can bring this wire, and we're not going to disconnect anything. We're going to measure across the resistor. I'd want to hook over here to the right because this is our voltage port. And I would hook over here right on top of where we had the other one. That's measuring what we call across the resistor, and it's going to give us some voltage reading at that point. We would be able to read the voltage across that multimeter, and it would give us some reading up here of maybe 1.2 volts or something. Now let's assume that at some point we're going to make this a little bit more complicated, and we might hook something up, several light bulbs up in series. Well, we would then go through the resistor. We might go from here to the next one, out of that light bulb, and then from here we go down here. Well, now we've hooked this up in series. The electricity has the current has one path to travel. It has no choices. All right. So we would hook our multimeter up again. If I wanted to measure the voltage across the first one, and now I'd be measuring the voltage across the first resistor, or the first light bulb here. Resistor, light bulb, the same thing. Oh, I've noticed a mistake I made over here. We need to go from the ports right here. Is what we'd want to be doing with that, and then I could take this one and continue it over here as well. So there's our wire that's connecting those two, and I'm now measuring the voltage across the first one. If I wanted to measure the voltage across the second one, I would remove the wire, and I would measure it now. I would hook up the prongs to the second one, and this will allow me to measure the voltage going across. And we use the terminology across the resistor because we're measuring across it. We're not disconnecting it. So that's what we'll do for measuring the voltage. Again, this was for measuring the voltage. Now in this example, I'm going to show you how to measure the amperage. voltage we measured across because it was the voltage drop across. We wanted to measure the difference. We measured the voltage on one side, measured the outgoing voltage, and what your multimeter then tells you is the difference between those two. But the amperage, we want to measure the current running through it. So let's start off here then. Let's put our multimeter over here again. It's a lovely multimeter. And let's put ourselves our common. We've got our voltage, but the one we're going to use now is the one on the left. Let's give ourselves a dial and a little reading out here. Let's go ahead and connect it up again. And I'm going to go ahead and hook up a couple of these. Well, as you can see, I've hooked this up in series because the electricity, the current has one path to go. So let's talk about this then. If I want to measure the current, well, I'm going to use this left side because this left side is what measures the current. And the common, I would use it as well. So let's figure out how we're going to hook this up. Well, we have to measure the current going through the circuit. And so what we want to do here is somewhere we want to disconnect the circuit and insert the multimeter into it, almost like it's a resistor. And it's going to read then what we'd be getting. Just so we can understand, I'm going to go ahead and change this wire color to a green one. That's not a good color to use, is it? I should have realized that. Let's make a blue wire. See how blue wire reads on here? Blue's kind of okay. So what I'm going to do here now is I'm going to disconnect this wire, and I'm going to put the ammeter into the circuit. From here, instead of going to the other resistor, I'm going to go up here and connect these two wires. I'm going to connect the wire coming out of here, make the current go through the ammeter because we're measuring the current. And now I'm going to take my ammeter and complete the circuit. To do this now, I'm measuring the current. What I'm actually doing now is measuring the current that would be going through the second light bulb. And that would allow me to find the current then going through here. And that would allow me to find the amperage. So we're not measuring across, we're measuring the current that goes through it. Okay, what I'm going to show you here now is how to find the amperage in a parallel. The reason this is parallel is the current here is going to go out of the battery, out of the EMF, and right here you notice it's got a choice. It can go, some of the current is going to go through the light bulb, but some of the current is not going to go through the light bulb, it's going to go to the next circuit. That then it has a choice. It can go through that light bulb, or it can go to the next circuit. It can go through that light bulb, and then all of it, all of the current, whatever went through this one, whatever went through this one, and whatever went through this one, all comes back together here and goes back to the battery. Well, actually I've made a slight mistake here, I've seen, because I had it coming out of the voltage. We want to make sure we're coming out of the, I measure the current side. Now I'm going to find the current going through the first light. But what I'm going to do then is I'm going to disconnect it right here. I'm going to find out how much current is coming through here. So I'm going to disconnect it. I'm going to bring this wire up here and connect them. And then I'm going to take my common and I'm going to complete the circuit again. Now I'm measuring the current going through the first light because it's how much current there was going through it. If I wanted to do the second one, I'd have to hook the first one back up, disconnect the second one, now hook the wire going up here, connect the wire here, or just take the black wire over to it. That might probably be the simpler thing to do. Now I think about it, I might just take the black wire, lead over, and I've completed the circuit again. Again, from this point, connect this up here. There we go. There's a connection. And what we've done here then is we have found the current that's running through the circuit breaker, or through the multimeter, and going back. That's the current going through the second one. And then at the end, we could test how much current is going through the last one. I would disconnect it. Let's put this one back in. And now what I'm going to do is I'm going to take the black one, and I'm going to finish the circuit. I'm going to take a red one from here. I'm going to connect it back up here. What we should find then at this point is that this should be the total current, because this is the sum of all three of these going back up here. And that should now be giving us some type of current reading up here of, let's just give it something. Some type of current reading up here. I don't know if it's going to be 4, but it should be close to that. Hey, this is how you read multimeters. I hope this was somewhat helpful for tomorrow's lab. I'll see you on the flip side.